In last video, you have learned about input and output port. If we have a circuit which is designed as input port, it is possible to use it as input port only. We can't use it as output port. In order to do that one, we need to change the circuit elements. Or in other words, we can say that we need to do some circuit arrangement or alternation to make it as output port. This is applicable in the case of output port also. That is, if we have an output port, in order to utilize it as input port, we need to do some circuit alternation. Suppose we have a circuit such that it will act as input port or output port depending on requirement, then this will reduce the size of the system, reduces the complexity in hardware arrangement, etc. In this type of system or circuit, it is possible to change the mode of operation from output port to input port or vice versa by changing code or changing programming. This type of devices are usually termed as programmable peripheral interface, that is PPI. In microprocessor based computer system, there is a widely used programmable peripheral interface, that is PPI IC, namely 8255. So Intel 8255 is a PPI used to implement parallel data transfer between processor and slow peripheral devices like ADC, DAC, keyboard, 7-segment display, etc. Here, the ports available in PPI can be programmed for input or output ports. This is the block diagram of 8255 PPI. Here, it is clear that this PPI contains three 8-bit ports, namely port A, port B, and port C. Also, it contains a control word register. Control word register is the core part of 8255. Why? Because the content or program in control word register determines whether the ports will act as input port or output ports. Coming back into ports, here it is to be noted that there is a provision of using port C as two 4-bit ports, namely port C upper and port C lower. Port C upper is MSB 4-bit, that is PC7 to PC4, and port C lower, it carries LSB 4-bit, that is PC3 to PC0. Considering this fact, in 8255, totally 8 ports are available. That is 2 8-bit ports and 2 4-bit ports. For the purpose of controlling these 4 I/O ports, they are divided into 2 groups. That is Group A and Group B. Group A contains port A and port C upper, and Group B contains port B and port C lower. Then data is transferred between microprocessor and 8255 through bidirectional data bus D0 to D7. The WR bar and RT bar signals are used for indicating to 8255 whether read or write operation to be carried out. If port is programmed as input port, then read operation need to carry out. Similarly, if port is programmed as output port, write operation need to be carried out. Then, in order to select or activate 8255 IC, it requires an active low signal to pin CS bar. That is, 8255 is selected only when CS bar signal is low. Suppose if we have one address line, the possible selection combination is these address lines may become either 0 or 1. So the possible combination is 2. Similarly, if we can have two address lines, the possible combination in these lines are 00, 01, 10 and 11. So 4 possible combinations are there. As we need to select 4 things, that is port A, port B, port C and control word register, we can use two address lines A0 and A1 in order to select IO port and control word registers. Remaining address lines along with IO by M bar signal is used to provide active low signal CS bar. It is to be noted that A255 is PPI. It is related to IO operation. So IO by M bar signal here is 1. So A255 interface peripheral devices to microcomputer. It contains three 8-bit programmable IO ports, namely port A, port B and port C, and control word register. Port C can be used as two 4-bit ports, namely port C upper and port C lower. So totally 4 ports are available, two 8-bit ports and two 4-bit ports. For the purpose of controlling for IO ports, there are two groups, Group A and Group B. Group A contains ports A and port C upper. Group B contains port B and port C lower. Data is transferred between MUPI and A255 through data bus D0 to D7. It is bidirectional. Then RD bar and WR bar signals are used for indicating A255 whether read or write operation to be performed. A255 is selected only when CS bar signal is low. Address lines A0 and A1 are used for selecting ports and control word register. And the remaining address lines along with IO by M bar signal, that is usually 1, is used for providing CS bar signal. Here it is clear that when CS bar signal is low, then only ports and control word registers are selected. If A0 and A1 are 0, then corresponding address is 00. Under that condition, port A will select. Corresponding to 01, address is 01. Port B will select. Corresponding to 10, the address is 02. Under that condition, port C will select. Corresponding to 11, the address is 03 and control word register is selected. If CS bar signal is high, A255 is not selected. So this is the schematic diagram showing how CS bar signal is generated by means of remaining address lines, that is A2 to A7 and IO by M bar signal. Usually A2 to A7 is 0, so that we need to complement by means of NOT gate. Then IO by M bar signal is already 1. So by means of NAND logic, we can obtain an active low CS bar signal. Next, let's see pin details of A255. It is a 40-pin IC. It works on 5-volt DC supply. It contains VCC and ground. So totally 2 pins are there, considering VCC and ground. Then there are 3 8-bit ports. Port A. Port A contains 8 pins. So 2 plus 8, 10 pins are available. Now port B is there. It is again 8-bit. So totally 10 plus 8, 18 will come. Then port C upper, PC4 to PC7. It is a 4-bit. So 18 plus 4, 22. Then port C lower, PC0 to PC3. So 22 plus 4, 26. As we discussed earlier, these ports are grouped into two, Group A and Group B. Group A contains port A and port C upper, and Group B contains port B and port C lower. Now considering VCC ground and 3 8-bit ports, total pins are reached to 26. Now data between A255 and microprocessor is transferred through bidirectional data bus D0 to D7. It contains 8 pins. So 26 plus 8, 34. Then in order to select this A255 IC, we need a CS bar signal. So 35 will come. Next is, in order to select port and control word register, we need address lines A0 and A1. So total pins become now 37. Next, in order to control read and write operation, two control signal is required, that is RD bar signal and WR bar signal. So total count becomes 39. Then in order to reset this one, we need reset signal. So total pin count become now 40. So this is the pin diagram of 8255. Here pin number 26 is VCC, pin number 7 is ground, pin number 4, 3, 2, 1 constitute PA0 to PA3, then 40 to 37 PA4 to PA7. Then port B starts from pin number 18, 19, 20, 21 to 25. Then port C lower is starting from pin number 14 to 17 like this. Then port C upper is PC4 to PC7, that is pin number 10 to 13 like this. Then data bus pins are from 27 to 34. Then CS bar signal is pin number 6. Then A0 and A1 to select ports and control word register is pin number 8 and 9. Then WR bar pin is pin number 13. And RD bar signal is pin number 5. And reset pin is pin number 35. So this complete pin diagram details and block diagram details of 8255 programmable peripheral interface.